Are you using Selenium for your UI and end-to-end testing? If so, stick around. We have 7 tips to write Selenium tests. Selenium is a popular and powerful UI testing library. Like all tools, it requires some degree of expertise to write good tests, and here are 7 tips to write better UI tests on Selenium. Number 1. Use the latest Selenium version. Compared to other frameworks like Playwright, Selenium is more finicky when it comes to version. If versions do not match pretty much what you expect, things can go wrong. For instance, consider the unofficial Selenium WebDriver Go client, the Vega/Selenium. Despite its popularity with thousands of GitHub stars, the library has not been updated for years and it still relies on Selenium 3. Having a wrong client version or the wrong Selenium version can be the reason for flaky tests. One of the problems with Selenium 3 is that it uses JSON wire protocol for communication with the web browser. The JSON wire protocol is not standard, this is legacy code. For this reason, Selenium 4 has deprecated JSON wire protocol in favor of the more stable and reliable W3C WebDriver protocol. That makes Selenium 4 tests less flaky than Selenium 3 tests. So to avoid issues in your test suite, always ensure you are using the latest Selenium version and the client libraries. Number 2. Prefer official Selenium bindings. Selenium officially is available on C#, Ruby, Java, Python, and JavaScript. Selenium is so popular that there have been a myriad of unofficial bindings for other programming languages. The problem with these bindings is that they may not be up to date and using the latest protocols to communicate with Selenium. Although you might prefer to use a different language for your test, it might not be the best idea from the technical standpoint. When you rely on an unofficial port, you are depending on the updates for the community. The contributors behind the project may not have time to keep up with the latest official releases. Other versions of Selenium are not supported by the official team and they're slower and more buggy. Even when using official bindings, you may have problems. For instance, in one of the Selenium TLC meetings, it was pointed out that the Ruby bindings tended to produce flaky results in Firefox on Windows. And this is an official binding, so even when you are using official bindings, you may present some flakiness. So you should keep an eye on the latest news to know ahead of time if you are going to have problems. Number 3. Standardize environment. The natural conclusion from the first 2 tips is that you should take care to match the environment across different machines. When I mean match the version, I mean the browser version, the Selenium engine version, and the bindings version. When you have errors appearing on one environment and not the other, you should check the log, you should check the versions to see if there's any difference. If your CI provider supports flaky detection, you should also rely on that. Number 4. Configure timeouts. The default timeouts are designed to cover most scenarios, yet they may be too short or too long for your use case. The main 3 timeouts are the script timeout, which is 30 seconds. This is the time it takes Selenium to wait for a JavaScript script to be executed with the execute script method. The page load timeout is 5 minutes. It's the maximum time a page can take to get into the ready state. The implicit wait timeout, which is 0 seconds, so there's no timeout, is the time Selenium waits for element to appear on the page. Considering that pages tend to be dynamic, a bad timeout can cause a lot of flaky tests. In this snippet, you can see how to configure each of these 3 timeouts. We can set them before the test code runs. Number 5. Use generic locators. One of the key aspects of writing a robust UI or end-to-end test is use effective selection strategies for your elements in the page. Selenium supports several methods to select HTML nodes. We can select by class name using the CSS selector, by ID, by the HTML name, by the links text, either the complete or the partial text, by the HTML tag name, or using an XStat expression. Let's compare 2 examples. The first one, the selectors are very tightly coupled with the structure of the page. Any change in the DOM structure may cause the test to fail. The first implementation can lead to a flaky behavior, especially when we deal with dynamic elements that appear and disappear during load. The second example is better because it's more generic, will tend to reduce reliance on the structure of the page and will lead to a better result. As a rule of thumb, the class attribute of any element, any node on the DOM can change dynamically, but its area role is less likely to change that easily. So targeting area roles is a better alternative than targeting elements in the page directly. Another alternative is to use ID attributes with their also less likely to change. Number 6. Spinners should appear and disappear. A spinner is basically an indicator to wait. So let's say we are trying to test the load more button. Clicking it makes a spinner appear while the data is loading. We may be tempted to wait for the spinner to disappear. It may cause the test to never wait and go past that and fail, and that usually leads to flakiness. So the cure for this flakiness is to click on the load more button, then wait for the spinner to appear, then wait for it to disappear, and then continue with the tests. Without this visibility and invisibility check, the test can be flaky. Number 7. Learn the difference between explicit and implicit wait. In end-to-end testing, we typically need to wait for elements and operations to take place. The simplest of solution is using thread sleep to wait for something to happen. This waits a fixed amount of time. This approach is called hard waiting, and while it's easy to understand, it leads to flaky tests. The problem is that we cannot beforehand how long an operation can take. Difference in the speed of CPUs or bandwidth can cause the test to fail, and hard waits also introduce artificial latency in your test. Selenium offers two alternatives to hard waits. One is implicit waits and the other is explicit waits. Let's analyze them both. Implicit waits are set via the timeout as a global setting that applies to every element location called in the testing session. The default value is 0, which means that if the node is not present when the code runs, they will raise an error immediately. When an implicit wait is set, the driver will wait up to that amount of time for the element to appear. So in this example, we are setting the implicit wait to 100 seconds. Selenium will wait up to 100 seconds for the button with the ID subscribe to appear. As soon as the element appears, it will resolve and click on it. Explicit waits, on the other hand, are wait loops that poll the test for a specific condition to evaluate as true before resolving and continue with the test execution. In this example, we are creating an explicit wait object. The driver will wait up to 100 seconds for the element with ID subscribe to appear on the page and will resolve as soon as the item is rendered on page. So comparing one with the other, the implicit wait only checks that the item, the element exists, while explicit waits are more comprehensive. It checks that the element exists, that it's visible, that is clickable, and the content is visible. So the tip is to use either implicit waits or explicit waits instead of hard wait, but also do not use both in the same test because that also can lead to conflicts. That's all I have for today. I hope these 7 tips made Selenium more reliable for you. If you like this video, please like, subscribe, and follow us for more content. Thank you for watching and have a nice one.